Alright, welcome back, Algebra 2. We're now going to jump into 6.4. This is in the middle of our Chapter 6. We're looking at transformations of exponential and logarithmic functions. And transformations is not a new topic. We've been seeing that pretty much in every chapter. For each function we've done, we've been doing some transformations. So look at those charts again. We'll have some charts, actually one for exponential and one for logarithmic in here. So we're going to transform the graphs of each of these, and we're also going to be writing transformations of graphs as well. But first, let's go to a little cartoon, a little Far Side cartoon. So here's this guy here with the big thing on his head. So donning his new canine decoder, Professor Schwartzman becomes the first human being on Earth to hear what barking dogs are actually saying. And so you can see what he says that they're all saying, hey, 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 hey. And the one in the back here is like, hey, or something like that. And he's probably howling. All right, so going on to our transformations now. We're going to look at this core concept on page 171. So take a look at that. This is what you want to be kind of constantly referring back to. I don't want to spend a lot of time going over this again. I've done it many times. One thing I just want to remind you, and you can write this up here, is that we see two kind of transformations, horizontal and vertical. You can see horizontal translation, vertical translation. There's a reflection in two different axes, and one axis is a horizontal axis, the other one's a vertical axis. So you see horizontal or vertical as well here. Horizontal and vertical on the stretching and the shrinking. So there's really two different types. And you got to realize what's going on with these two different types. And the horizontal are inside with x. So if we look at all the horizontal ones, so that's this one here is horizontal translation. There's an h number on the inside there with x, or where the x is. In this case, they're all exponentials. So that means that x in the exponent spot is going to either say x minus 3x plus 3 up in the exponent. You're not going to see parentheses now with these. It's just going to be in the exponent spot. There's going to be a number where the x is. So if it's where the x is, that's going to be a horizontal translation, shifting you right or left. And if it's stretching or shrinking down here, you can see horizontal stretch or shrink. You can see the a numbers in there where the x is. Okay, so that's what's going on. So up here in the exponent spot, it's going to be 2 times x, or x divided by 2, which would be like a 1/2 x. The reflection, the horizontal one, is going to be right here. So we want to think of this as our horizontal reflection. So we'd say horizontal, let's write it down over here. This is our horizontal one because it's inside with x. The negative sign for reflections is going to be in there with x, making the x negative in the exponent. Horizontal, that means that if it's over the y-axis, that would be a vertical reflection, because it's not inside where x is. The negative sign is not where the x is. The negative sign is out in front. And that's what the verticals are all about. They're on outside, either in front or behind the function. So you can see the vertical translation. There's a k number on the outside. So here's where our number is here. Here's the h number on the inside on that one, a number on the inside of this one, the negative signs on the inside there where the x is. That's going to be all our horizontal ones. But then maybe I should make those blue really, as I'm thinking about the color anyways. So these were all the blue ones for horizontal. Horizontal here, horizontal there, and there, because they're inside there with x. And I'll make these ones green for vertical. Vertical are on the outside, so our k number is on the outside. See here? There's where the x is in the exponent, but then it says plus 5, minus 1. That means it's going to be shifting it up or down. Or here's the negative sign here, outside of x. So the x is, its negative sign is in front of the a number, front of the whole function. Or same thing here, the a number here is outside in front. So you got your base is here, but then it's being multiplied by some a number out in front there. It's no longer 1. See, in this case right here with basically all of these, the base number is 4. The a number would be 1. There's no a number there. So if you do have an a number for this one, now the a number is in front of the function, as you can see right here, 3 or this 1/4, causing stretching or shrinking. And just remember that, especially with stretching and shrinking, is it a stretch or is it a shrink? So it's based always on the factor number. So stretching and shrinking is based on these factor numbers over here. So the factor numbers are the reciprocal of the numbers if it's horizontal, as you can see here. The number here is 2, and your factor number is 1/2. That's a reciprocal of 2. Or in this case, it's like a 1/2, the refactor number is a 2. But in the vertical one, the factor numbers are exactly what is in front here. So these are the factor numbers. 3 is the factor number, 1/4 is the factor number. So if the factor number is more than 1, it's going to stretch, as you can see here. So these two right here is more than 1. More than 1. It's going to stretch. But then these ones over here, do like that, these ones are less than 1. Less than 1 is going to shrink. So they'll shrink if the factor number is less than 1. If the factor number is more than 1, then it's going to be stretching. As you can see, stretched by that. If it's less than 1, it's going to shrink. All right, let's move on to some problems as we try these. Okay, so with 1 and 2 on our extra practice, page 173, it says describe the transformation of f represented by g, then graph each function. And I'm going to kind of graph the function first. Let's go ahead and just graph this first exponential function, which is just 6 to the x power. So we'd want to just plug in some numbers for x to be, and so I'll just make a little table of values for that. Just -1, 0, 1, and 2. Just 4 numbers is fine. You might want to go 5 sometimes. But we know when we plug -1 here, it's just going to flip that. It's going to make it 1/6. So there's our 1/6. When we plug in 0, we know that's going to be a 1 right there. 6 to the 0 power is going to be 1, just like anything would be. And then 6 to the first we know is going to be 6, and 6 squared would be 36. So that gives us some quick numbers there. And then we're just going to put that on our graph here. And so I'm going to just show you what the graph is and then kind of show you how I'm mapping this out. So make sure you draw your coordinate plane down here at the bottom, your x-axis down below, y-axis can go right through the middle. So what we're doing here is going to be going about every box. I think is going to be worth 2 on this one, I believe. Yeah, every box is worth 2. So there's 0, 1 right there, half of a box. So when I'm going to -1, it's just going to be half a box this way. I'm going to be just going up a little bit. Then there's 0, 1. And then then there's 1 right here. We're going to go up to 6. That's 3 boxes up. 2 is 1 box this way. And we're going to be all the way up to 36. So that's going to be way up here. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So 18 would be actually right here. So I'm not even going to be here. So I'm a little bit on the left side of where this is, because 36 would actually probably be way at the top of my screen. So you just show that you're going to do an arrow there at the top and show it's going to keep going up. So we're actually not really going to see that point because it's way higher than our graph. Well, now let's talk about the transformation from this graph here to this one. The only thing different is this +6, which is a k number. Okay, that's a k number. It's outside after the function, so we know it's a vertical translation. Going to be shifting us up 6 units. So if we go 6 units up here, that's going to be going 3 boxes up basically. Right now what this does is it shifts the asymptote, because the asymptote is the x-axis on this one, and now the new asymptote for this one's going to be up here at 6. So we'll have a kind of horizontal line right through here. Same graph, it's just going to be moved up 6 units. So it'll look like this. Just going to show you. Actually, let's first write this down. It's a translation 6 units up. That's the first thing you want to do, is just describe it. That's describing it, is just write that out. Translation 6 units up, and then we're going to draw it on our graph here. So I'm going to put this kind of green dashed line for my asymptote, and now every point is just going to do kind of the same thing. So if I kind of think of this now as was the x-axis, this is like our new x-axis. So we're going to do kind of the same thing. We could say it's going to be 0, 1, half a box up. 1, we're going to go up 6. 2, it's going to be way higher, so we're not going to get there. If we go to -1, it's going to be up just a little bit. So there it is. Again, just like we did these. Or if you want to think about it, you're going to basically add 6 to all these numbers. So this is going to be 1 plus 6, which would be 7. So 0, 7, that's where this point would be. Or this is going to be 6 plus 6, which is going to be 1, 12. So here at 1, we're going to go up to 12, which is where this point is right here. So there's another way you can see that. You can also use the Desmos calculator to verify your graphs just to make sure that they're correct. Okay, going on to number 2, we see E is the base. So this was like 6.2 when we were talking about the natural base E, which we know is the number 2.718. And we might round it to 2.7 just for shorten it up a little bit sometimes. But let's go ahead and look at what this graph would look like. So I'm going to do a little table of values again. Same numbers, -1, 0, 1, and 2. So if I do -1 here, e to the -1 is going to make 1 over 2.71. So I can think of it as like this. 1, let's clear this out, 1 divided by 2.71 2.7 or 2.718. We can maybe do that. Oops, not 8 there. I'm going to say 2.718. That's the most accurate we can get. So about 0.36 or 0.37 would round it to 0.37. So there we can round that. 0 power, that's always going to be 1. To the first power, that's just going to be our number for e, which is 2.7. I'll just round it to the 2.7. And then if we do it squared, we do that 2.718 number again, square that, that gives me the 7.38 number. So we can just say that's what that one is. I'll just round it to 7.4 just to shorten it up a little bit. Go ahead and graph this one. Our asymptote is going to be the x-axis again, just like it was on 6 to the x. It's going to be the same here. And so we just start to see this one. Let's check out what the graph looks like. So it looks like every box is going to be worth 2 again. Yeah, 0, 1. So 0, 1 is right there. And then go to 1. I'm going to go up to 2.7, which is right here. Yeah. So there's 2 and 0.7. So every box is worth 2 again. So same coordinate plane as we had over here, and the same numbering as well, every box being worth 2. So when I come over here to 2, I'm going to go up to 7.4, which is about right there. And there's our graph, our exponential growth graph for that one. Now if we describe the transformation, notice where the number is. It's up here in the exponent with x. So that's going to be also a translation. So these are both translations. This one's a translation up because it's a vertical translation. This one's going to be a translation horizontally, left and right. And since it's an h number, it's always the opposite of what we think. So even though it says x minus 4, h really is positive 4 on this one. So our transformation is going to be described as translation 4 units to the right. So right would be for, because it's positive for h number. So don't look at this sign for the direction, look at the h number sign. You got to change the sign for h. So h really is the opposite of what this is. And now you can see it's right. And now we'll do the same thing. We're just going to move all these points 4 units to the right. In fact, you can just do that and move this one 2 points right this way. So there's 1, 2, 3, 4. That's going to go here. This one's going to go 1, 2, 3, 4 this way. The asymptote will still be the same thing. We're just going to shift all these points 4 units to the right, every one of these points, and then just draw a new graph, and there it is. That's all it is, just 4 units to the right for each one of these. You can see 1, 2, 3, 4. There I'm at that point. So that's all you have to do on that one for g of x. Okay, on page 172 you see this core concept. This one just is the same chart, except now it applies it to the logarithms over here in the examples, but exactly the same thing. And I'm not going to explain it anymore because it's all the same stuff. Your horizontal ones are in there with x. Your vertical ones are on the outside here with x, just like this one is as well. So there's, inside with x is horizontal. Flipping over the y-axis, this one's going to be outside with in front of the x, so it's the vertical flipping over the x-axis. Same idea with the stretching and shrinking. All of this is the same stuff. So let's apply that now. We're just going to do some that apply it to the logarithms. Okay, back on page 173, right there in the middle of the page, 3 and 4, we're going to apply that to the logarithm graph now, just all the transformations. So let's first look at this first logarithm. We're going to first, let's just graph this first one, then we'll look at the transformation that we're going to be seeing from f of x to g of x. So just graphing this first one, the first thing we're going to want to do is realize that f of x is our y. Okay, if that's our y, then we're going to make this into exponential form. So that means that 5 is the base, y would be the exponent, and it's going to equal x. That's the first thing we want to see, is just change it from this form into 5y to the x equal 5 to the y power equals x. That way we're going to plug in numbers. We're going to plug numbers in for y, not x. So that makes it a whole lot easier when we're going to try to graph this logarithm function. Change the logarithm to an exponential form and then plug numbers in for the exponent. And the numbers we'll plug in are just going to be our numbers like -1, 0, 1, and 2. Just some basic numbers right there around the 1, around the 0. But again, we're putting them on there for y this time, not x. We're picking numbers for y. We're going to plug it in. So I'm going to see on this one it's going to be -1. We're going to flip that upside down, and we'll see we'll get 1/5. And we're going to put negative in, it just flips what we have. So that becomes 1/5. Anything to the 0 exponent we know is 1. And 5 to the first power, we're going to see as 5 on that one. 5 squared on the next one is 25. And so there's our 4 points. We can plot these points on our graph. What should the asymptote be? What is the line we're not going to cross on this one? And on these basic ones like this, when it just gives you a logarithm like this, the asymptote's always going to be the y-axis. So this y-axis here is going to be our asymptote line. We're not going to cross that. So our graph on this one will look like this in blue. So it's not going to cross this y-axis line. So here's our numbers, our 1, 0. So 1 is 0 right here. So going by 2's again on this one. So if I come over to 5 on the x, 1, 2, 3, 4, 5, I'm going to go up 1. And 25, well, obviously I'm not going to get to 25, so I'm not even going to go up to 2 yet quite a bit. I'm going to be underneath the 2 as I put my arrow here. And this one's going to be, there's that point at -1 right there on the y-axis, and just a little bit to the right of the y-axis for that point. And it's going to come down, just keep getting closer to it. Alright, so let's look about the transformation now. What's going on here? There's two things that are happening that are different than this log base 5 of x. We still have the log base 5. It has to be the same base, of course. And we still have our x in here, but now we have a 1/2 in front of the log. We have the +7 inside there with x. So those are the two things that we got to talk about. There's two transformations we're going to have to describe. First, let's describe this with the 1/2. Because it's outside in front of the function, that's going to be a vertical word, and it's either going to be a stretching or shrinking. So if it's outside, the factor is the 1/2, which is less than 1, so it's going to be vertical shrink. And so that's what we want to say there, vertical shrink by a factor of 1/2. And then we talk about this +7 inside here. So this would be an h number because it's inside with x. So the h number is always going to either go left or right, but it's always going to be the opposite of what we see here. So really it's going to be -7, which is going to go 7 units to the left. Negative means going to the left. So it's really going to translate, or translation, 7 units to the left. So that's what we talk about with describing the transformation from the f of x to the g of x function, how this is going to be translated. And now if we want to graph this function, we can, it's not hard to do translations on graphs. We can just move points around. But it is a little bit more challenging if we want to try to shrink something by a half here. So that's a little more challenging to just figure out where these points are going to be. So really what we should do is just graph this one like we normally was going to graph it. Do a table of values again, get some more points for this one. The one thing we do realize is since the y-axis here was the asymptote for this one, the y-axis is not going to be the asymptote for this one. It's going to be that -7. Since h was -7, it's going to be over here. So 2, 4, 6, 7. This is where our asymptote is going to be right here. So that definitely will have moved to the left 7 units. So let's start with just changing this log into, just like we did here, change it to exponential form. First thing we got to do is get the log by itself though. So this 1/2 has got to move. Remember this g of x is y. I'm going to multiply both sides by 2. So 2 times y over here will now equal my log by itself. So now the logarithm is now kind of by itself. It's log base 5 of this part here in the parenthesis. So now I can change it. My base is 5. My exponent for it is going to be 2y, and it's going to equal the x plus 7. So this is what we have as an exponential form now. 5 to the 2y power equals x plus 7. And we're going to put in some numbers for y. So this is my t-chart that I'm going to use. I'm going to plug numbers in for y here. Notice I didn't choose the same ones here, -1, 0, 1, and 2. I chose -1/2. And the reason why I chose that is so that I can say 2 times a half is going to be a 1. That would give me an easier number, I think, to work with. So as we plug in the -1/2 here, that's going to make this -1, which will make it a 1/5 equal to x plus 7. So if I subtract 7 from both sides, if I take 7, or I should take 1/5 away from 7, it is going to be a negative. It's going to be -4/5 on that one. Because the 7 is like 6 5/5, and so you just take 1/5 away, now you get -6 4/5. If I put 0 in here, 2 times 0 is going to be 0, so 5 to the 0 power is 1, so it's going to be 1 equal to x plus 7, and when I subtract 7, I'll get -6 for the 0. When I plug in the 1/2, that'll just make this 1, which is be a 5. 5 to the first power is 5, so 5 is equal to x plus 7. Subtract 7, we're going to get -2 for that 1/2. And then for 1, if I do put in 1, it's going to be 5 squared, which would be 25. So 25 is equal to x plus 7, subtract the 7, and we're going to get a positive 18 on that one. So this is probably the point that we may not actually see on the graph. So as we start to plot these points, it's going to be, remember I said my asymptote is going to be over here at -7. You can draw a line, kind of a dashed line through it there. And so that's where we see this. My green dashed line is the asymptote. And here's my points. It's a little more steep, as you can see. It's a little more jagged of a curve. It's not as smooth of a curve as this blue one was. It's a little more sharp of a curve. So as we start putting these points in, and remember everything is going to be worth 2. So even if I go to -6, there's 2, 4, 6, 0. There's that point there. Negative 1/2 on the y. That's going to be up here, kind of, because 1 would be right here. It's going to be right here about -6 4/5 or so. Well, actually, no, that's going to be over here. Sorry. So yeah, -6 4/5, which is going to be really close to 7. We're going to go down a half. This is the one that's going to be right here, -2, and then up a half. And then we're not going to see this point. That's going to be way, way lower. So if I go to -1, and or I should say 18 on the x, that's going to be a little bit different there. So 18 on x, that's a much further out. We're going to be at 1. Actually, I'm sorry, that's going to be this way, not this way, obviously. 18 on x is this way, this direction. We're going to be at 1. So 2, 4, 6, 8, 10. There's 10. 10 would be here, but 18 is going to be kind of further over here. So a real sharp curve. All right, looking at the next one here with 1/3 as the base. So let's go ahead and graph this one first. Graph the f of x. Let's change it into exponential form. F of x is our y. So 1/3 is the base, y is the exponent, and it will equal the x. So right there, there's our exponential form. 1/3 to the y power equals x. Let's go ahead and put in our table of values. I'll just use those basic numbers again. So when we got -1, we're going to flip this. So I'm going to flip 1/3. We're just going to get 3. To the 0 power, it's still going to be 1. To the first, we'll see it's going to be a 1/3. And when it's, I put -2 here, so that way we can flip the 3 and then square it. So when it's a -2, it will flip it, make it 3 squared, and now that's a 9. And then when we want to plot that one, go ahead and plot those. Again, our y-axis is the asymptote. This time it's coming like this, as you can see. It's going a different direction because the base is a 1/3. This one was a base, was a 5. That's why it's a little bit of a different direction. But as you can see, here's the points. Looks like, again, everything is going to be worth 2. So 1, 0 is going to be up here. So 1 on the x. Actually, it's right here, sorry. 1 on the x. I keep getting myself turned around sometimes on these. But yeah, 1 is the x, 0 is the y. It's going to be on the x-axis. 3 on the x. So 2, 3. We're going to go down to -1 on the y there. Here's 9, -2. So 2, 4, 6, 8, 9 will be here. -2 is there. And then this one here at 1/3 and 1. So 1/3 is right there. And go up to 1. And that's kind of what you can see. The curve's going to be that way. I just know it's not going to cross the y-axis. So that's why it's not over here. It's going just kind of right up on the y-axis there. So now when we're looking at the transformation from f to g, there's only one thing different with this -4/3 behind here. So that -4/3, we also can think of it as a 1 1/3. So that's a k number, which means it's going to be going down that much. We're going to just be shifting all of these points down just 1 1/3 of a point. That's it. So as we describe this, it's going to be a translation again down this many units. So translate 4/3 of a unit down. And as we start to do this one, we can just kind of think about this one. I'm not going to do all of this for this one. I think I can probably just move it down 1 1/3 of a unit. So I go down 1 unit here, I'm here, and then 1/3 is going to be just a little bit below there. 1 unit's half a box, and then 1/3 just a little bit more. So half a box and a little bit more for each of these points. Half a box, just a little bit more, and that's where our graph will be. There you can see it, g of x. That's all I did. Half a box and a little bit more for down 1 1/3, because all it was is just shifting it down. It has the same asymptote. In fact, didn't change the asymptote because there's nothing in here for x. If there's something in here for x, like we saw here with this, x plus 7, that changes the asymptote. All right, well, our joke of the day says, what lies at the bottom of the ocean and worries? A nervous wreck. A little play on words. Okay, moving on to the last couple there on So 5 and 6 now, go back to your extra practice. Okay, 5 is an exponential function, 6 is a logarithm function. So we're going to first, let's just graph this f of x1 like we've been doing. So this is going to be plugging some numbers in for x. Let's go ahead and just pick some numbers on a table of values. So I'm going to just pick those same numbers, -1, 0, 1, and 2. And if I plug in -1, that's going to flip what we have, so it just makes it a 5 there on that one. If you plug in 0, it's always going to be your 1. And we plug in 1, that's going to be our 1/5 that we have. And if I plug in 2, that's going to be 1/5 squared. So it's going to be 1 squared, which is still 1. 5 squared is 25, so 1 over 25 for that one. And then we just go ahead and plot our graph again on this one. Remember, our asymptotes for these are horizontal asymptotes. This is going to be the x-axis being the asymptote this time. And so as you start plotting your points, we'll see that 0, 1, let's say that's going to be 1 box. Every box is worth 1 on this graph. Go ahead and draw your x-axis and y-axis the same way as you see it here. And we can start just putting things in. So -1, we're up at 5. So 1, 2, 3, 4, 5 is right there. There's your 0, 1 point. At 1, we're just up at 1/5. 2, we're just a little bit above that x-axis at 1/25. And you can see it's a decaying problem coming down. It is less than 1 for our base, so that makes sense. That's what decay is. Decay is less than 1. We're still going to see decay on this next one, but it will just transform from our basic one to this. It's got a little bit more stuff going on. So as you can see, when we compare f of x now to g of x, the exponent now has a -3 in front of the x, and the function's got this +4 behind the whole function. So that's actually 3 different things there. So when we try to look at it, so you have this -3, the negative sign is a reflection, that's one transformation. The 3 is one of the stretching or shrinkings, that's another transformation. And then your 4 is a translation, that's going to be your k number, shifting it up or down with this number behind here. So let's start talking about one at a time. First about reflection. So the negative sign up in here with x, when it's with x, it's a horizontal reflection, or we would think of it as a reflection horizontally in the y-axis. It's going to flip over the y-axis. And so that's what we want to remember there as we look back at that chart, is reflection in the y-axis. Because we don't say horizontal reflection. We tell you, we say what axis is in for reflection. We just got to realize that if it's horizontal, it's in the in the y-axis, going left, right here, going over this y-axis. Then we have the 3. The 3 is going to be a stretching or shrinking. Now, if it's again with the x, it's going to be horizontal, and we actually will use the word horizontal here. But remember, we have to think that the factor number is going to be the reciprocal of 3, which is 1/3, and that's going to be less than 1. So it's going to be horizontal shrink, and it's by that factor of 1/3. So horizontal shrink by a factor of 1/3. So when it's with the x, it will become the reciprocal. The factor number is the reciprocal of that number. So the factor number is 1/3, and it's a shrink because that factor number is less than 1. And then the last one is just the translation. It's going to go 4 units up. Then it's a +4. That's our last one. Translation 4 units up. So all of that's happening here. And we're probably going to need to write another table of values and figure out some more points, because we have a reflection, we have a stretching, we have a shrinking here. If it was just translation, that's easy to do. I can translate things 4 units up and move them, but when we're going to stretch and shrink stuff, we really should go back to another table of values for this. So I'm going to put in another table of values for this function here, where we have, when we plug in numbers for x, we're going to have to multiply it by a -3. So I would choose some numbers that would give me some easy whole numbers, which would be 1/3 and -1/3. So I'm going to plug in -1/3 for x right here. That makes it a +1. So 1/5 to the 1 power, that's going to be 1/5 plus 4 then at that point. So 4 and 1/5 is what we have, 4 and 1/5. When you plug in 0, -3 times 0 is 0. 1/5 to the 0 power is still 1. So that's just going to be a 1 plus 4, which will give us 5 for that one on 0. If you plug in the 1/3, so 1/3 here will make this into a -1 exponent, which will flip this. So the negative exponent will flip it upside down, making it 5. 5 to the first would be 5, and then just add 4. So 5 plus 4 would give us 9 for the 1/3. And now if we just start plotting these points, we'll be able to get it. So if I go to -1/3, remember every box is worth 1. So -1/3, that's this direction. So about right here, we're going to go up 4. 1, 2, 3, 4, and then a fifth is just a little bit higher, not much more than that. 0, 5, you're going to be at 0, you're going to be up here at 5. So 0 and then 5 on the y-axis. If you go to positive 1/3, we're going to be even higher up here. So we can kind of see where we're going to be at. Notice that the asymptote on this one moved. Notice that I moved my asymptote, it's not the x-axis anymore because we have a k number. The k number will move the asymptote on these exponentials. So that moves it up 4 units there. So go ahead and draw that new asymptote with a dashed line right across there at 4. And there's your points there. It's coming down this way. It's going that direction out. All right, coming over to our logarithm. So remember, on logarithms, the asymptote is going to be vertically. So on this first one, it's going to be the y-axis. And what will shift that will actually be an h number. This one does have an h number in here. So we're going to be shifting our asymptote a little bit. We'll see that as we do it. Let's first start just graphing this one. So remember, this is our y. Log x. Well, if there is no base, you don't see a base in here, it just says log x. That's the common log, which is base 10. So we can just put a little 10 in here, log base 10 of x. And then we can say 10 is the base, y is the exponent. So 10 to the y power is equal to x. So now we're just going to plug in some numbers for that y this time. So the same numbers that I've used before, negative 1, 0, and 1, 2. So the negative 1, we'll flip this and make it 1/10. The 0 will make it into 1. The 1 will make it 10, and the 2 will make it 100. So 10 squared is 100. We probably won't see that point. And so as we're graphing this, and we know our y-axis is the asymptote, there's our graph. So as we start to plug in numbers, we're going to say 1/10. Let's see what we're going to be, 1, 0. So we're basically, every box is worth 2 on this one, as I can see. So make sure every box is worth 2. It's going to be going right down the middle, right across the middle, but every box is worth 2. So when I say 1/10, I'm just going to go just a little bit to the right, and then I'm going to go down to negative 1, which is half a box. And then there's 0, or there's 1, 0. If I go to 10, 1, so 2, 4, 6, 8, 10 puts me here, 1's right here. I'm not going to be getting to 102, obviously. That's going to be way out to the right. But you can go ahead and just graph that one. Remember your asymptote here. It's going to just kind of do a waterfall situation right in front of that y-axis. Now if we want to try to describe again what we have here. So 2 things I see are different. This negative 3 is in front, which actually is 2 separate. We got to see that as really 2 separate transformations. The negative sign is a transformation all on its own. The 3 is another transformation. And then I also see this negative 2 inside here with x. So there's really 3 things to describe, 3 transformations to describe here. So this is our y, our g of x is our y, and we have negative 3, that's one thing that's different, and then this minus 2 inside here. So let's first again talk about the reflection. So this is on the outside, which means it's going to be a vertical reflection over the y-axis. It's going to flip vertically, up or down, flipping. So that would be reflection in the y-axis. That's the first thing you could say, or sorry, x-axis. So that's x-axis is always going to be a vertical flip. It's going to be flipping over the x-axis. Then the next thing we want to see is that 3. So the 3 is also on the outside, which is going to be a vertical stretch on this one, because remember this factor number is going to be always the same. You don't flip it here. You only flip it when it's going to be horizontal like we saw over here. So this one's going to stay the same. The factor number will be 3 because it's on the outside. It's a vertical stretch, since that's more than 3. Vertical stretch by a factor of 3. And the last one is it's going to be an h number inside here. H will actually be positive 2. So that means it's going to go right 2 units. So translation, right 2 units is our last one. So those are our 3 descriptions of the transformation. We got to make sure we're describing these one by one. Sometimes we only have 1 to describe, sometimes 2, sometimes even 3 to describe. And again, I would do a whole new graph for this one as well. I'm not going to try to just move points around. So let's go ahead and try to first put this into exponential form. I got to get rid of that negative 3. So I have to divide both sides here by negative 3, because remember that g of x is my y. That's why I put this here. G of x is the y. I'm going to divide both sides by negative 3. So y over negative 3 is now going to equal my logarithm. So now I can put it in exponential form, where this is log base 10 again, and I wrote the 10 down here, log base 10, and they are in the same base, that's why we're able to do this. So log base 10 of this exponent, y over negative 3, is equal to x minus 2. So that's my exponential form. And now I just want to put numbers in for y, and I'm going to try to be strategic here. I want numbers here like 3 and negative 3. That would make this into a 1 or a negative 1 exponent. That will be the best probably options. So that's my y numbers are going to be negative 3, 0, and 3. So when I first plug in negative 3 over negative 3 is a positive 1, which is just 10. 10 to the first is just 10. And then we just got to add 2 to both sides. That's going to give us 12. So 12 comma negative 3 is 1 point. When I put 0 in here, 0 over negative 3 is going to just be 0. And so 10 to the 0 power would be 1. And so now we're going to see 1 equals x minus 2. Add 2, that's going to give us 3. 3 comma 0 is another point. When I put in 3, that's going to give me a negative 1 as an exponent, which will make this a 1/10 number here. So 1/10 equals our x minus 2. And now when I add 2 to this one, I'm just going to get 2 and 1/10. So I get to say it's 2 and 1/10 when I add 2 to the 1/10. Now when I plot these points, so we might not see 12 and this negative 3. So x is 12. So that was 10 here. 12 would actually be a little bit off the graph. We might go over here. It's not too far off. Go down to negative 3. And actually, you can see my point right there. It's in red. There is the point for this first one. If I go to 3 right here and 0, I'm going to be right there on the x-axis. And then if I go to 2 and 1/10, which is right about here, I'm going to go up 3 units. And we'll see we'll be up here like this right here. And so we're going to be coming down this direction because it's going to be a reflection over the x-axis. So it'll look like this. Our asymptote, like I said, is going to change. It's going to go to the right 2 units right here, translate 2 units to the right. So we're going to translate our asymptote 2 units to the right as well. So it was at 0 on the y-axis. Now it's over here at 2. X equals 2 is our asymptote. And so that's our graph there. So you can see how it did a reflection over the x-axis. It flipped over that. It stretched a bit by 3, and it also did translate 2 to the right. Alright, we're almost done. We actually have 2 more problems we're going to do, and I'm going to have you put those on page 172. First, I want to show you these 2 problems are going to be like the ones we're going to put on 172. It says, let the graph of G be a reflection in the x-axis followed by a translation 4 units to the right of this graph f of x equals 2 to the x. Write a rule for G. So here we are writing a new function. So it's kind of like, if I go back to our one here where we did this one, let's just say this one here. If this was the function they say, okay, and they told us all of this, they said it's going to be reflection y-axis, horizontal shrink by a factor of 1/3, translation 4 units up. What is the G function? We would have to write this ourselves. So that's what they're doing now. We're just given the information, we're given the description, we're given the function here, the first one, the f of x. We got to write G now. And so that's what we're going to try to do here on this next one. So the first thing to do is to realize we got to do a reflection in the x-axis. And so that's going to be multiplying. The x-axis is the vertical reflection, remember. So that means the negative sign is going to be outside in front of the function. So it's going to be in front of this negative 2. So negative and then 2 to the x. That's the first thing to do. The next thing then is to do a translation 4 units to the right. Well, right is horizontal, which means that's going to be where the x is. So if I want to, that's an h number. So if my h number is 4, to plug it back in, that's actually going to be x minus 4. So that's what they're going to see here. Here we go. So x minus 4 is what we actually have to replace the x with. And that's all we have to do. Now it's going to say negative 2, and then x minus 4 is the exponent, and that's our answer. There's our function here. G of x equals negative 2, x minus 4 is the exponent. Let's look at one more like this, and then we'll do 7 and 8. So it says, let the graph of G be translated 2 units up, followed by a vertical stretch by a factor of 2 of this logarithm graph. We're going to write the rule for G. So the first thing we're doing is we're going to translate 2 units up. So that's a k number, which means we're going to add 2 to the back of this function. That's not hard to do. Just put plus 2 after this x. It's not going to be in a parenthesis. If it was in a parenthesis, that would be an h number. So we don't put a parenthesis here. It's just going to be the function, then plus 2. The next thing we do is this vertical stretch by a factor of 2. Well, since it's a vertical one, it means it's also in front of the function, and that does not change the factor number. So we're going to put 2, actually we're going to multiply this whole function by a 2. Not just put 2 in front of the log here, but we're going to multiply this log by 2 and also this 2 by 2. It's like a distributive property. So it's going to be something, oops, put the wrong, okay, sorry about that, click the wrong button. So here you can see that we're going to multiply the whole function now. This whole thing here is our h of x function. We're going to multiply the whole thing by 2. So 2 times this whole thing. We're going to distribute the 2 inside here. So 2 in front of the log, and then 2 times 2 will make that 4 in the back. There's our new function for g. That's what we're trying to write. Okay, you just do one at a time. Do the first one that it says, and then do the second one to the one you just did here. So we have to do the first one, do the second one to that. All right, so on page 172, we're going to put 2 more down. Okay, so page 172, right underneath the kind of chart for the logarithm transformations, there's a notes section there, a big section for you to do this. First of all, I want you to copy down number 7. So you may want to pause the video and copy that down and then go ahead and play it so you can see how I'm doing that. Okay, so you should have number 7 copied down by this point. And it says that it's a horizontal shrink by a factor of 3. That's the first thing we'll do, followed by translation 2 units up of this graph, e to a negative x. Okay, so first thing we're going to see here is our h of x here, or what we're going to do here is going to be saying we're going to have to do this horizontal stretch by a factor of 3. So when it's a horizontal, it flips the factor number. So we're going to do the reciprocal of that. That's 1/3. That's going to be our factor number. It's going to be in there with x, so it's going to be 1/3 times x. So basically, we're going to replace the x in this function with a 1/3 x. And so now it'll look like this. So that's what we're putting it there. We're going to multiply that negative times our 1/3 x. So that's when we put the negative sign still there. So now that's just the first one. If that's all there was, that would have been our answer. But we have one more to do. It says followed by translation 2 units up. So if we're just going to translate it 2 units up, we're now going to put, we're going to add 2 to the back of this function here. So that's not hard to do. So we're just going to be saying, okay, this part is our h of x. We're just going to add 2 to it. So when I add 2 to that, it's just e to a negative 1/3 x power plus the 2 on the back here. That's all it is. There's our answer for g of x. G of x equals e to a negative 1/3 x power plus the 2. Okay, for number 8, go ahead and copy down number 8 next. And let me pause the graph, and then you can finish up what we're going to do. Okay, so you should have copied number 8. We're going to have 2 things here as well. Reflection in the y-axis, then followed by translation 4 units to the left of this log base 10 of x. We can just say log x, that's the common log. So for number 8, here's what we're going to do. Reflection in the y-axis first. So the y-axis, that's going to be flipping over the, I'm sorry, not that way, flipping over the y-axis going this way. As you can see, I'm going left-right when I'm doing that. So that's going to be horizontal. So that's going to be in there with x. So horizontal is always inside with x. So our negative sign is inside with x. So we're going to replace the x here with this negative x. And so it's going to be log, and then in parentheses, negative x. Now we want to make sure the parentheses is there. If you have a negative sign, make sure you put parentheses in there. If there's something there with x, put the parentheses around it. Then it says to translate 4 units to the left of this function, which means we're also going to put something in here as well, because that's going to be left is also horizontal. That's an h number, 4 units to the left. That's negative 4. But when you put it in, it's going to change signs to x plus 4. So we're really going to replace now the x with an x plus 4. So we're going to replace the x inside here with an x plus 4, which is negative times that. So negative times each of these. And so that's what you can see here. Negative times this x plus 4. Distribute the negative into that. It's negative x and a minus 4. So our function now will look like this. G of x is equal to log of a negative x minus 4. And that's our answer. So just do one thing at a time, and then you should do okay. Okay, just take one transformation at a time. You only have to do 2 here. So just one at a time, and you should be okay. All right, that concludes our lesson for 6.4, and I'll see you guys later.